Good evening, everyone. My name is Wong Di-Yuan. I am the group leader. I have another three members. The first is Edward, the second is Yongfu, and the last is Ansheng. Today, I will talk about my project presentation on TAO1221. This presentation is divided into two parts. The first part is paper review, and the second part is simulation exercise. The paper review topic is notification-oriented computer architecture, prototype, and simulator. This paper presents a new solution called notification-oriented computer architecture for executing software development according to the NOP computational model. The design of NOCA is based on the principle of generality and scalability, so it can execute NOP software of any size by fetching the application from memory. The proposed architecture is organized as a 5-gram multiprocessor that executes instruction hierarchy through a dedicated set of processing cores. This paper also presents experiments performed on an NOCA simulator extending the scale of parallelization of application. The results show that the speedup is maximized at higher level of parallelization, as well as minimizing the impact of processor to memory communication bottleneck by reducing the number of memory access required during execution.
And the title is a subway of computer architecture, simulation, technical, and tool. Simulators are used by computer architects to evaluate various design possibilities, test new research ideas, and compare the performance and power consumption of various processor types. Because of the large number of configuration and minor factors that might create line difference in performance, analytical models are not used for evaluation architecture. Simulation is often regarded as the gold standard for performance modeling. Simulators are used in the birth of push research to evaluate the performance of novel concepts.
Good day, everyone. My name is Ong Yong-fu. So this is my paper review, and the title is In-Memory Computation-Based Mapping of KCHF Hash Function. KCHF is actually quite new methodology by KCHF team, which is a permutation block of the third generation secure hashing algorithms that using the simultaneous LIN-based methodology, and it is implemented based on the sponge construction. The logic gates which are implemented on it are exclusive OR gate, AND gate, and NOT gate. So using this methodology, it helps to detect the attacks and allow authentication of data origin for downloads from sources over the internet, for example, using the clouds. So in this article, the writers mentioned they were using emerging non-volatile memory technologies such as CBRAM, OXRAM, PCM, and FERAM in their experiment. In result, they found that energy delay product reduced due to data transfer and shift operations is higher than the SLIM operations. Also, the SLIM methodology helps in realizing the universal NAND logic gate using any two terminal NVM devices exhibiting MLC. So that's all from me. Thank you.
Good day everyone, my name is Vincent. Today I'm going to present my paper review. The title of this paper is called Performance Analysis of Network-on-Chip Topologies for Arbor's Multi-Core Processors. The summary of this paper is look at how to construct networks on chip for multi-core processors using the 6th generation Arbor's architecture. The features and scalability of networks with 2D mesh and 2D direct mesh topologies were investigated while keeping the physical design restrictions of the chip architecture in mind. The network models were created using the Verilog description of real switches and took into account all the technical process physical properties. As a result, the system of device connection within the CPU was revised. The solution was based on the creation of a distributed network on chip, in which devices are connected to a shared distributed switching environment with a predetermined topology through network adapters. And this is my introduction and summary of my paper review. Thank you everyone.
This our part B first question. Here is the result of the global misread and using different thread file brought in case size. In the experiment with higher or rising case size, there will be models of reduced probability of a majority conflict and malfunctioning. These mid-range have stabilized as a result of another element, which is that the data was still present when the program ran, and this factor was linked to the penalty rate, which caused the mid-range to become more steady. The great difference equated to nil memory address improving the case size would be reduced. It will eventually result in a significant increase in miss rate performance because the miss rate for each program is different. The large difference in miss rates will not appear at the same time for all programs. In conclusion, an increase in cache size do not furiously improve system performance as we increase the number of processors. The total amount of cache increase, therefore, it usually result in a drop in capacity miss.
Here is the result of the global misread using different trace file and the change of block in cache. This experiment, it may be observed that for great cache size, the misread is stabilized because of the compulsory miss are independent of the cache size. This great difference indicate the memory location are so close together. Even a small increase of cache size may make a big difference in performance. This great difference in misreads do not appear at the same point for all the program. This great difference of misread appear at different point for all the program based on the situation because every program is different in size and the memory location of it is randomly allocated. Conclusion, the increase of cache size improves the multiprocessor system performance. More work can be stored in the block and the mesh rate will be reduced when we increase the cache size or block size. However, there are some compulsory mesh which are learned from the cache size when increasing the cache size. That's all. Thank you everyone.